So let me start by introducing Pinchin and who we are and why Pinchin is the right choice for your needs. Pinchin has been a leader in engineering and environmental work since 1981. A lot of our clients and you all on the line likely know us from how we founded our company. We started as an asbestos company and we decided we needed to diversify our services because eventually one day we will have remediated all asbestos in buildings. They won't be putting it in buildings anymore, and we're going to need some other stuff to do. Well, the funny thing is, hazardous materials work is still one of our main disciplines here at Pinchin over 4 decades later, but we have expanded and we do a lot of work now. So we do work in indoor environmental quality, occupational health and safety, building sciences, mechanical engineering. We have a host of services to help you manage your indoor and outdoor environment. Pinchin is a rather large company now. So not only this graphic shows us all across Canada, but we're also expanding into the United States. And one of the real benefits about Pinchin is that we have local offices all over the country, but national experts. So you're getting the local travel fees of your local consultants, but national experts to rely on with decades and decades of experience. We have a whole host of employees that have been here since our company started in the early 80s. So truly decades of experience to lean on. And we'd be happy to connect you with any of these other services. Feel free to message me and I would love to give you our contact info. So a little bit about the presentation and myself. Thank you for joining. My name is Heather Swail, and I'm the operations manager of the Indoor Environmental Quality Group in Richmond, BC. I'm lucky to see we have people all across the country here today from East Coast to West Coast. So thank you all so much for joining. I have been with Pinchin for the last 13 years now, which seems like a long time, but it's really flown by because I can say I like what I do. Right now, my role is overseeing the day-to-day operations of the indoor environmental quality team. So we do a lot of indoor air quality, we do radon work, we do mold and water damage, building certifications like LEED and BOMA, all kinds of that stuff. I've also been CNERP certified for over a decade, and CNERP is the Canadian National Radon Proficiency Program. So that's Canada's certifying body for those who have radon measurement and mitigation. And we'll talk more about why that's important later. But this is a field that I'm quite passionate about and I've been practicing in for a long time. So I'm happy to share my information I have on this topic with you all. Some of the feedback I've had in recent presentations is radon the new asbestos, or is radon the next silica? I've been hearing a lot about it lately. And we're probably hearing about it, first of all, because it's November, which is Radon Awareness Month. And secondly, because yes, we are doing a lot more education on the topic. As more and more research comes out, there's more information for us to share, and we're learning a lot more about the dangers associated with radon. So I'm hoping I can share that information for all of you today. So what we're going to cover, we have a couple topics. So the first thing is, what is radon and why it's important? We'll highlight the risks associated with radon exposure and why it's a concern for building occupants. Then we'll look at how radon gets inside of buildings. So understanding those pathways and factors that contribute to elevated radon is critical for also learning how to fix it if you have a problem. We'll also review legislation and guidance currently in place for radon, which will help define what the compliance requirements are and what the best practices are for addressing radon risks. And then we'll go on how to implement a radon measurement program. What are the steps? What are the tools to measure this effectively, and how to make sure you're doing it properly? And then we'll get into now what, if you have tested your building and it's high, where do we go from there? So we'll address what the solutions are for elevated radon levels. And then finally, we'll wrap up with some of the new construction requirements that there are in place for new buildings that we're building, and some proactive radon design considerations. That is our agenda for today. So let's start with the basics. What is radon? You've definitely heard of the word because you're in this presentation today, but radon is a naturally occurring radioactive gas, and it forms as part of the decay process of uranium in soil, in rock, and in water. Even though it's a natural part of the environment, it's important to note that it's colorless, it's odorless, and it's tasteless. So we don't know if it's here without testing. I think that's another reason why not everyone is an expert at radon already, and why not everyone knows the risks associated with it is because we don't have someone to blame in this scenario. It's natural. The air you're breathing right now has radon in it. The problem is when it gets to really high levels and gets trapped in buildings, that's when it becomes hazardous. But when I compare it to asbestos, which I did earlier, that's something we put into buildings. That was something that we could blame. But this is natural. It's something that was really no one's fault. It's just something in the air that we are breathing. So as I said, radon is in virtually all of the air we breathe. It's indoors and outdoors. The issue is when it accumulates inside and we get those really high levels. That's when we see the significant health risks that are associated with radon, which we'll talk about on the next slide. So understanding this it lays the foundation for the next sections, which we'll talk about, and we'll also go through how to measure it and mitigate it effectively. So the biggest health concerns associated with radon is it is the second leading cause of lung cancer after smoking. It's a very serious health issue. The image I have on the slide is showing what the Canadian numbers are associated with radon lung cancer deaths. It's about 3,200. In the United States, that number is elevated significantly with 21,000 deaths per year. And to put that in perspective, we'll look at the next slide, is compared to other deaths, such as drunk driving accidents, car accidents, it's almost double what the deaths of car accidents are. So just putting that in perspective, how serious this health issue is. And what happens is when radon gas breaks down, it produces radioactive particles that you inhale when you breathe, and they damage the cells of your lungs, which can cause lung cancer over time. And we'll talk about that a little bit more in the next slides as well. So getting into the health concerns, let's take a little bit of a closer look here how it impacts our health. So I mentioned when radon breaks down, it releases what's called radon decay particles, or RPDs. They're tiny radioactive particles that can attach to your lung tissues when you inhale air. And the RPDs, they continue to break down. So they release alpha particles, which is a form of radiation. And these are highly energetic and cause significant damage when they come in contact with your very delicate lung cells. So over time, this leads to damage and mutations, which can increase the risk of developing lung cancer, particularly if you've had long-term exposure to these elevated radon levels. And unfortunately, if you've ever met someone that has maybe been diagnosed with lung cancer, but they've never smoked a cigarette a day in their life, radon was likely the cause of that illness in that case. So it's difficult because you can't see it, you can't smell it, or you can't taste it, radon and its decay products, it's difficult to really grasp what their presence or activity do. But this is a photo of a cloud chamber, and a cloud chamber allows you to see the alpha particles in action. How it works is it creates this super saturated, leave visible trails as they move through the chamber. And the alpha particles are released by radon decay products, which they'll be observed in these short little tracks. And I'll show you a video in the next slide. And the beta particles leave a little bit longer and thinner trails. And this visualization helps you make the invisible threat of radon a little bit more tangible. And it's a really powerful demonstration that you can kind of picture what's happening in your lungs, what you breathe in. So I'll show you on the next slide. Here's a video. And if you can see these little flecks dashing across the screen, that is the alpha and beta radiation, which is going on in your lungs. So you can imagine how damaging that can be over time and how that can cause lung cancer. So how does radon get into buildings? We mentioned where radon originates from. So it originates from soil and rock underneath buildings. And due to a positive pressure under the slab of a building, like in this picture, the gas is naturally driven upwards, seeking the path of least resistance. The building is acting like a vacuum and it's sucking all of that soil gas, not just radon, all soil gases into the building. So any opening, cracks, gaps, any openings in the foundation or expansion joints, utility penetrations, even porous concrete, that's all a pathway of radon to get into the building. In this slide, we show the concept of using a smoke pencil, and a smoke pencil shows the movement of air and gas. It makes it a little bit more visible. So you can see in this picture, it actually looks a little bit like a neutral pressure. The smoke is slightly flowing to the side. I'm not sure if you can see my cursor, but it's definitely not going underneath the slab. Whereas in this slide, this is what happens when a building is under positive pressure and the ground beneath the slab is under negative pressure. And in this case, that is due to the installation of a radon mitigation system. So in this case, the radon mitigation system is creating a negative pressure underneath the building slab, and it's pulling the radon gas from the soil and redirecting it away from the building through a venting system, which we'll talk about a little bit later in more detail throughout this presentation. But it's very effective. You can see in the smoke pencil on this slide, the smoke is very easily being sucked down through the foundation. And this is really showing the effectiveness with your eyes of how effective radon mitigation systems work in a building. So one of the primary reasons revolving doors were invented was to manage the air pressure differences between inside and outside buildings, especially for larger structures like high-rise buildings. So buildings with a significant height or an advanced HVAC system, they often have pressure imbalances due to factors like wind or mechanical ventilation or even temperature differences. And when buildings are under positive pressure, there's higher pressure inside compared to outside. So air naturally pushes outdoors and it can make conventional doors difficult to open and swing. They act like a barrier almost against escaping air. You may have noticed this before if you've ever opened the door to the building and it feels like a gust of wind is blowing out at you. That is the pressure effect. So that's why we invented revolving doors for these issues. So you don't get the feeling of being sucked in or pushed out of a building, depending on the pressure of it. So let's take a closer look at the common entry points for radon in buildings. A very common question that I get as a consultant is, my work doesn't have cracks in the building. It's a relatively new build, so I don't think we have a radon problem. But this diagram highlights how radon gas, because it comes from the soil, it can infiltrate various openings. And this really demonstrates what some of those common pathways are. So certainly, yes, cracks in the foundation are a common pathway. Because radon is a gas, even small cracks allow radon to seep in. But there's lots of other factors as well. So construction joints are seams where there are different parts of the foundation meet, and they often leave gaps that radon can enter. Utility penetrations is another one on this drawing. Openings around pipes, electrical conduits, HVAC systems, they all provide a direct pathway. Crawl spaces and sump pits, those are areas often exposed directly to soil, making them a significant source of radon entry. And porous concrete and masonry as well, even solid looking materials can allow radon to pass through it. And also, finally, water sources I wanted to touch on. Radon can dissolve in water supplies, particularly in areas with high levels of radon in the ground. So this could be common in things like well water, which would release radon into the air during any water activities like showering or doing your laundry or washing the dishes. Oh, sorry, guys, I went backwards there. So the next slide, this similar, but it has one other visual I like. Footings and floor drains are also natural gaps in construction, which are connected to the soil area and usually unsealed, so another channel for radon. So all of these points, even the most well-sealed building has the risk of having elevated radon in it. And the next part of that, sort of plan B, is it's important to understand that radon does not discriminate to type of building. Regardless of its construction or its foundation type, radon can be equally as prevalent in a building with a basement, if it's slab on grade, or a crawl space. So the key takeaway is that radon entry points do exist, and the only way to determine if radon is inside your building is to test it. In fact, one little joke I tell in some of these presentations is really there's only one building I would recommend. I would say you're safe. You do not need to test. I'm not, if you guys are awake on the line, if anyone can get creative and wants to throw in the chat what they think that building would be, we'll see if anyone's brains turned on. I'm on the West Coast, so it's pretty early for me, but maybe the East Coasters are a little bit more awake and creative. Excellent, Chris. Chris typed in a floating house, and that's exactly right. So if it was a tree house or a house on stilts, yes, if there is no contact with the ground, there is not a risk of radon. That would be the lowest risk to test. But if your building is in contact with the ground, radon testing is what I would suggest. Thanks for participating, Chris. I appreciate that. So now we'll talk about how radon is distributed throughout a building. The highest concentrations are usually in the lowest level. So that could be a basement or that could be your first floor, depending on your building layout. And that's because that is the closest level to the ground where radon is originating from. And it's often the closest and connected to those radon pathways, like the sump pump or the cracks in the foundation, like we mentioned earlier. As we move up the building, so in the next floor up, the first floor in this example, radon levels usually dilute from 40 to 60% lower than the floor below it. And that reduction occurs because of dilution. So the radon is starting to get mixed with the other air in the building. And also the mechanical ventilation is also usually on the main floor, which can help disperse radon. And then as we move up further to the second floor and above, we're close to what outdoor levels are. The radon has been even further diluted as it's traveled upward, and it's the furthest away from the source. So as we move up a building, we're getting less and less radon. Another thing to point out that's kind of interesting, though, is if your building has elevators. Elevators can distribute radon throughout your building. As it sucks up the building, it can bring that air up with it. So there are some recommendations of how to test multi-level buildings as well, which we will go over. So radon variability in buildings, it doesn't just matter by floor, but it also matters the footprint of the building. This is a building that I tested a few years ago. This is a school. You can see its L-shaped design here. And this is why it's really important to do a thorough radon testing plan. The rooms in red tested high for radon over Health Canada's action limit, and the rooms in white were below Health Canada's action limit. So when we talk about a comprehensive radon testing program, it's really essential that one test is not sufficient for testing your building and knowing if you have a radon problem or not. It could have been very easy in this school to have missed a large problem if we only deployed one or even several detectors. We could have easily missed the problem here. And I've had some questions in this presentation before about why this happens. And there's a couple of possibilities in this case. One is the proximity to radon entry points. So rooms located near cracks in the foundation or those utility penetrations, or if they're poorly sealed with areas like the sump pits and crawl spaces, they are more likely to have elevated radon levels. There's also could be ventilation differences between the rooms. So rooms with better airflow or better mechanical ventilation may dilute the radon more effectively, which would lower concentrations. There's also the soil composition and building design. So variations in the soil beneath the building and variations in floor construction can cause localized differences as well. And then also the pressure differentials. So rooms with the different HVAC settings and air pressure conditions might draw radon at different rates. So it might pull in radon to an adjacent room with neutral pressure. So that kind of shows some of the highlights and why we need a really comprehensive program. If you believe you've tested your building before, but you've only deployed one or a couple of detectors, that is not sufficient. This case is actually something quite common we see in public buildings.
Hey, Heather, just to
Yes.
interrupt you for a second, there's a question in the crowd.
Oh,
So, there's a question saying, what are the units of radon concentration?
in Canada, we use becquerels per cubic meter, and you are a very critical thinker on the ball. We have a slide in the next about, I think, 4 or 5 slides that are going to cover what the units are and what the guidelines are here in Canada and in the US. So thank you for being on the ball. But right now we'll get into the exposure guidelines for radon. Specifically, we'll start off with the Canada Labor Code, and then we'll compare them to Health Canada coming up in a few slides, which is directly related to this question, so your timing is impeccable. But currently, the Canada Labor Code sets permissible radon exposure limit for federally regulated workplaces at 800 becquerels per cubic meter. That threshold is based on old standards. It's quite outdated, and it does not align with Health Canada's guideline, which recommends indoor levels do not exceed 200 becquerels per cubic meter. So recognizing this discrepancy, the federal government has proposed amendments to the Canada Labor Code, so it will align with Health Canada of 200 becquerels. We're actually expecting that alignment to occur this coming year. So if you have a federal building, there is a regulation upcoming that will be lowered to 200 becquerels, which matches Health Canada's current guideline. So if you are a building owner that has federal tenants or you are a federal workplace, now might be the time to test to get ahead of the Canada Labor Code change. Certainly doing this before an influx of companies are doing it at the same time will help manage costs. And it's also the season to do radon testing right now. The heating season is when we should be doing testing as opposed to summer. So just some other interesting places that have regulations for radon. The Yukon is actually a huge at the forefront of radon. They're taking significant steps to address radon exposure. So in this case, what I'm showing on the slide here, what's pretty notable is they're requiring testing and mitigation in childcare centers. It's part of their licensing requirements there. And that applies to all new and existing childcare centers. The Yukon is also conducting radon testing in schools and government workplaces. They're really leading the forefront of the radon charge. I didn't see anyone in the line here from the Yukon today, but very, very interesting that we have a leader here in Canada. I like to show this map because this shows radon testing in schools throughout Canada, and it highlights the status of testing in publicly funded schools. This map is from 2017. It's the newest data we publicly have at the time. But what it reflects is really a huge variety on who has tested their schools. Some regions like Yukon, which I mentioned earlier, Prince Edward Island, New Brunswick, Saskatchewan, they've all achieved 100% radon testing in their publicly funded schools. So they have a really strong commitment to ensuring a safe environment for their students and staff. There are some other regions in the middle, like Quebec, which have shown some progress, but not complete yet, but they're at 57%. And then in contrast, there are several provinces and territories that have just barely scratched the surface. I am currently in British Columbia, and we've only tested 8% of schools here. Alberta has only tested 3%. Manitoba is also at 8%. The Northwest Territories, Newfoundland, and Labrador are all at 0%. So this variation, it really underscores the lack of a unified nationwide approach for testing radon in schools. So some regions are really leaders and others are lagging behind. And I recently met with a school here in BC and some of our other clients, and the impression I've received from some of them is that they don't think there is radon in the province or enough radon that makes it willing to test. And I think what this data really demonstrates is that we don't know yet. There hasn't been enough testing completed for us to really definitively say that answer. 8% of schools tested in BC, for example, is really not a wide enough population to say your schools are safe or not safe. There's a lot more work to do when it comes to radon testing. So the general duty clause, this is in various provincial occupational health and safety legislation across Canada. But what it is it requires employers to take reasonable precautions to protect the health and safety of their workers. So this duty would extend to hazards like radon. So while radon-specific regulations don't exist in every province, the general duty clause is what obligates employers to act if they become aware of a radon risk. So continuing to chat about the radon guidelines in Canada, Health Canada's action level for radon is set at 200 becquerels per cubic meter. And this level represents the concentration of radon gas at which action should be taken to reduce exposure. Becquerels per cubic meter, it's a measurement of radiation indicating the amount of radioactive decay occurring in a given volume of air. And prolonged exposure of radon above 200 becquerels per cubic meter significantly increases the risk of lung cancer. However, you might also notice in this image that if radon levels exceed 600 becquerels, that's when Health Canada recommends immediate action and mitigating the building within a 12-month time frame. And that guidance highlights the urgency of addressing higher levels of radon to minimize the risks sooner. So for levels between 200 to 600 becquerels, remediation should be undertaken, but the timeline is within 2 years. So the intention behind this is to prioritize mitigation in the highest risk areas first. So the very elevated levels over 600 becquerels. And I can give you just some feedback from my personal background with radon is Pinchin used to have a radon lab, and I was the person that analyzed the radon samples in the lab, or one of those people. And I've seen radon levels much higher than 600. I've seen radon levels of 5,000 becquerels, 600 becquerels, and not altogether that uncommon either. You can get elevated levels very, very, very high that are not surprising to me anymore. And again, the take-home message, the only way to know if you have a problem in your building is to test for it. Now, looking a little bit more globally, the US, and we'll talk about the World Health Organization, the US uses the Environmental Protection Agency. The EPA has an action level of 4 picocuries per liter. That translates to 148 becquerels per cubic meter. You know, Canada and the US, we have to do temperature, we have to do Fahrenheit. We're always at odds when it comes to different units. So the US is actually, they have a lower action limit than we use in Canada. And globally, the World Health Organization, or WHO, further has a lower limit. They recommend 100 becquerels per cubic meter. And another thing I wanted to point out from the EPA is that the EPA emphasizes that there's no level of radon that's completely safe, and any property owner is encouraged to mitigate even if radon levels fall below this action level. You're thinking about cumulative risk and exposure over time. And a trend I'm seeing is as a consultant is that some of our clients are actually choosing to use the World Health Organization standard and not Health Canada. They're using a more strict guideline when it comes to making decisions about their buildings. So an interesting trend that's occurring. Health Canada has developed some comprehensive guidelines for radon testing to make sure that the testing is done accurately. And they have guidelines for residential dwellings and for public buildings. We'll talk about both of them a little bit. So in residential dwellings, so this is in homes, James, you have a question about, is there a way to encourage schools to perform testing? That's a great question. With some of the schools that I work with, they have done testing based on community suggestion, community complaint of testing in the schools. That's been the most effective way that I've seen testing being completed in schools so far. It's brought up at board meetings and so forth, and that sort of encouraged some schools to get ahead of the game. Just diving back into residential dwellings. So a radon test should be done for a minimum of 3 months. It's not a quick sample where we can grab an air sample and send it to the lab. It's a long-term test that's recommended for at least 91 days. And where it should be located in a home is in the lowest lived-in level of the home. So if your home has a basement and it's finished, maybe your office is down there, or there's a kid's bedroom, absolutely you should test the bedroom. Any room where people are spending 4 hours or more a day. If you don't have a basement, you would test whatever an occupied room is at the lowest level. There are some rooms to avoid. So we want to be in a room where people are spending at least 4 hours a day. And we want to avoid areas like bathrooms or kitchens that might have exhaust fans. So a really good place to deploy a test kit would be a bedroom, a living room, in those common areas. So in a home, generally, you only need about 1 test per home. If you were testing a row of townhouses, that would be 1 test in every townhouse. But when we get into public buildings, it's the same theory, but we're testing a wider footprint. So like when I showed that floor plan of the school, we're testing multiple locations. So all occupied rooms on the lowest level. So in the school, the photo I showed before, we're testing all of those classrooms, any offices, any of those occupied areas. We avoided bathrooms, janitors' closets, mechanical rooms. We want to test the concentration where people are spending their time. So it's really a similar theory of we're testing the lowest level, 4 hours or more a day, but we're testing in public buildings a much larger footprint. So there's more testing to do. So we'll chat a little bit about portfolio testing programs. This is something we do quite frequently, and it's important to be practical and take a strategic approach when we're looking at a huge plethora of buildings. And what we'll do is we'll start with high risk areas. So we'll think about a couple of different factors. We'll consider the building construction. Does the building have a basement or a crawl space? Is it in a radon prone region? We'll look at some historical testing data and some maps on the next slide of high radon potential areas. And we'll also consider heavily occupied buildings. So is this an office building where people are working from home mostly and there's an average of 5 people there a day? Or is it a school that's at full capacity every single day and there's many more people at risk for exposure? And with that information, we use that decision making to make a phased approach. And usually we'll split it up into 1, 2, or 3 phases to rank the highest priority buildings to test first. So the ones that we would deem high risk areas get tested in phase 1. So let's look at the radon potential map of Canada. So this map is something we use when it comes to portfolio testing to aid in our decision making, and it illustrates the radon potential zones across Canada. So it's the visual representation of the area where high radon levels are more likely, and this is based on geological conditions. So the zones in red, that's zone 1, and those are the areas with high potential, the highest potential. And that's just based on the geology conditions. There's more uranium in that soil. Zone 2 is elevated, that is green, the green sections you can see on the map, and those have moderate potential. Zone 3 is guarded, that's the blue zones, those have the lowest potential. However, although I've discussed that there's elevated, guarded, and low potential, what's very important to note is that radon can still occur in any building. I've tested many buildings in blue zones that are still high. There's lots of geological variability, and also there hasn't been a significant amount of testing done to really definitively say my postal code is this, is there a radon problem? We need a much larger sample size to get answers like this. So testing everywhere is still necessary. However, this map helps us with regional prioritization. If we're doing a portfolio, we might consider doing areas in zone 1, the high level first. Year 2, we might consider elevated, and year 3, the guarded levels. So further, that was the map of Canada, but a lot of provinces in Canada have their own breakdowns as well. In this photo, we have Alberta and Ontario. And in the next slide, we have Manitoba and British Columbia. This is something you can Google. Radon Environmental has put out this data, and it's something that you can access for free, I believe. And this helps us break down within each province as well. So beyond just that soil data, we'll look at some more building information as well to help prioritize the building. So we'll look at the building type that will determine the age, when it was built, if it's a tight, well-sealed construction, or is it older, maybe a leakier building with more air exchange. We'll also evaluate if there's an HVAC system, how it's designed and operated, and if we know what the ventilation rates are. We'll also see if there's any exposed soil in the building. So is there an open floor crawl space that has exposed soil? Is there a sump pit? And lastly, building height is also a factor. So radon, it's typically highest in the lowest areas of the building, so basements and ground floors. And the more floors it has, the more radon can disperse. So we talked about it diluting up a building. So that's another thing we will take into account when looking at a large portfolio. So it's really important to understand all of the factors to develop a tailored testing program for our clients. So just to hit it home again, even though there are some known hot spots, it's really important to test everywhere. The high uranium content in the soil, it does lead to a likelihood of elevated radon levels, but that tells us nothing about the building. You might not have a radon problem in a high radon area because of your building construction. So there's so many factors that go into it. We've seen variability, like I showed in the school layout, variability even amongst a building where some rooms are high and some are low. So really the only way to know is to test. And we'll get into testing in the next slide, but something I think about is I hope all of your buildings have carbon monoxide detectors, you have smoke detectors and smoke alarms. This is the next test you need to have in your buildings, is doing a radon test for that same purpose to ensure the occupants' health and safety. So getting into the actual measurement now, we discussed the locations. Let's talk about the tools we use. Health Canada recommends a long-term test, as I stated. So that's a minimum of 91 days. And it's also recommended to do this testing during the heating season. So typically right now is a good time to test. And that's important for a couple of reasons. First of all, windows and doors are typically closed, so that limits the ventilation and allows radon to stabilize indoors. Also, we have a greater stack effect, different pressure in the winter. So we're testing under the worst case scenario. That's why testing in the winter is really key. How we typically do this testing is with an alpha track detector. That's what you see on the screen here. That's actually one model, but what I'm holding up here is another model of an alpha track, but they're very small. Radon pucks is what a lot of people call them. They're passive devices. So they're installed by a senior professional in an appropriate location. And some of the thing that's really great about these is radon testing prices. It's very inexpensive to do radon testing in your building. You can buy them in bulk, so price will range depending on how many you need, but they're quite inexpensive, anywhere from about $25 to $30 a test. So really, even testing the full footprint of your building is not going to put you too much out of pocket. And at the end of the testing period, the alpha tracks go to a lab and a report is generated with what your radon test results are. So that's a very good, this is the most common way to test your building are these alpha track detectors in a long-term test. So heating season, at least 3 months. It doesn't have to be exactly 91 days, as long as that's the minimum. So short-term testing, long-term testing is the most reliable, absolutely, but there are some scenarios where short-term testing would be useful or necessary. Short-term testing lasts for 2 to 7 days. Some can go up to 30 days. And what scenarios we use it for is for real estate transactions. So sometimes for time-sensitive situations, for buying or selling a property, you'll do a short-term test to get a quick indication. However, every short-term test is recommended with follow-up of a long-term test, because we'll show you in the next slide, but radon levels are extremely variable. Also for diagnostic testing, so when we're evaluating the effectiveness of a radon mitigation system, we'll put in this middle picture. This is a continuous radon monitor. It's basically a computer that will log your radon levels for a period of time, every minute usually. And that will show us if a radon mitigation system is effective. If the radon levels were very high, and then a mitigation system was installed and we have a huge dip, we can conclude that that system is working effectively. And again, the two most common types, we have an alpha track detector on the right-hand side. That's called a Rapidos in this case. In the middle, we have a CRM, that's the continuous radon monitor. And on the left-hand side, we have an EPIRM. That's a little bit of dated technology now. It's not used very frequently anymore. But all three test devices, again, are pretty cost effective in this case. This picture demonstrates why we do a long-term test. This is a radon test done over 100 days. So it was a long-term test, and you can see the variability over the test period. Now, if we did a short-term test, it would be very easy to get a false high reading or a false low reading. We want to get the average over that period so we know what the average exposure is like. It's very easy to miss or identify a problem if you're not doing a long-term test. So how do we mitigate buildings? I've convinced you it's important. It is essential to test your buildings for radon. And now you found out your building is high. What do we do? So first, we'll talk about the role of HVAC systems. It's an effective strategy for mitigating radon in buildings, and really it involves leveraging the HVAC system to control radon levels through pressurization and ventilation. So HVAC can help create that positive pressure inside the building, which will prevent radon from being drawn in from the soil beneath the foundation. That is the primary way this happens. You can also improve air exchange rates, so diluting indoor radon levels by bringing in more fresh air. You may have heard the saying before, dilution is the solution. It can be an effective way to reduce concentrations. But some considerations with this is it depends on the design and capacity of the HVAC system, as well as the building size and layout. Also, any HVAC adjustments, it needs to be carefully calibrated so you're not creating any unintentional pressure imbalances that could draw more radon into the building. We have seen that happen before, unfortunately. And in some cases, a dedicated mitigation system, which we'll talk about in the next slide, a subslab depressurization system, is necessary in conjunction with HVAC systems. So it's something that could be considered as a standalone plan, but you might need to do it in conjunction with a subslab system, which we'll talk about next. So a sub-slab depressurization system, it's a very highly effective mitigation method. It's widely known to significantly reduce your radon levels, and we'll break down how it works. So what you can see in this photo, this round thing is a fan. That is a fan, and there is usually 4-inch PVC pipe that's going all the way below the slab. In this case, it's a basement. It's going beneath the basement. So it creates a suction pit beneath the slab and connects to the pipe, and it is exhausting the radon outdoors away from the building. It's a continuous system, so this fan is not run intermittently. It runs 24/7, and it's highly effective. This is really the gold standard for radon mitigation. It can reduce radon levels by 99% in most cases, so it's reliable, it's durable, it works really well, and it's relatively simple to operate and install as well. This is a typical system that we would install in really a large building or a residential setting. What we might find in a larger public building is that we might need a couple of systems to cover the full footprint, or we might need a larger fan. That's why it's important to hire a CNERP certified person to do this design. Is you want to make sure you're covering your whole building and not just a room or two rooms. You want a solution for your full building. So looking at that depressurization, one of the first slides I showed you was the positive and negative pressure. And when a mitigation system is on, you're seeing this smoke pencil, the lower photo, where the smoke is going beneath the slab. That's when a mitigation system is turned on. So it creates suction underneath the slab. And the before picture we have, radon is getting into the building, And afterwards, there is suction pit beneath the slab, and it's exhausting outwards. So let me show you what this looks like from the outside of the building. There's a couple of considerations of where you might design the exhaust point in buildings, climate being probably the number one factor in this case. In the left-hand side, you see what we typically call sidewall exhaust. That's when we're discharging immediately out the sidewall of the building. And then we have a roof exhaust on the right-hand side where we go all the way up into the attic and exhaust out the roof. But we have to consider climate's the big one in this case. Before I was with Pynchon Richmond, I was with Pynchon in Winnipeg, and we would have to do this sidewall discharge because in -40, you get a lot of icing up problems and you need your system to work effectively. But in most more temperate climates in Canada, we would be using this design on the right through the roof. In Canada, it's usually going to be one of these systems. If we were in a southern state, sometimes they would take the fan on the outside of the building as well. But again, because all of Canada is in a colder climate compared to Texas or Florida, we need to keep that fan working in an area where it's not going to shut down because it gets too cold. And this is what it looks like. The radon mitigation systems are prone to icing up if you don't put it in the right area. There's a lot of condensation that comes from these systems, so they're moving really quite a bit of moisture. And if you're in a very cold climate, you will get this icing up problem, and there will be fan damage, reduced performance. Is the system available for retrofit? Yes, you can install a system in an existing building. That's very common. And we'll talk about new construction and how we're incorporating that as well coming up. Thanks, James. So follow-up testing, once you've installed your radon mitigation system, this is a continuous radon monitor we put in a building, and this shows the levels were about 2,500 becquerels in this building. And as soon as the fan was turned on, it took about a day for the levels to even out, but you can see how low and effective a radon mitigation system is. This was a sub-slab system, and I think levels went down to close to 30 or 40 becquerels, if memory serves correctly. So a huge reduction, 2,500 becquerels to about 30 or 40. That's close to what outdoor levels are. Extremely an effective system that is quite powerful. And really immediate results as well. Now we'll speak about readily remediated new construction. So this is what we're doing for new builds, for buildings that haven't been built. These techniques are a critical part of radon design and construction to address radon entry before occupancy. In the previous designs I showed you, that's what we would do in an existing building, and this is what we're going to do when we're in the building process. So there's two things to talk about, a passive versus an active system. So radon new construction typically involves a passive radon mitigation system during this phase. So this allows venting piping from beneath the slab to let radon naturally escape to the outside without requiring a fan. It's very cost effective. And what's good about it is if you test the building afterwards and radon levels are high, it's quite easy to add the fan later and finish the system. So you're really already halfway there in that case. However, some of the cons we've seen with this is that if this has to be designed as well, a senior person needs to be incorporated into this design because we've seen the passive systems being installed in inappropriate places, for instance, under a stairwell. Well, if the radon system is high, we're not going to drill to finish the system through your stairwell to attach a fan and go all the way up. That doesn't make a lot of sense. It has to be thoughtful and effective when installing these systems in the design process. There's also some other areas of that are incorporated into the radon side. So we'll talk about sealing potential radon points. So cracks and joints are sealed. There's a soil gas membrane, which you see in this picture, also known as a vapor barrier. That's installed beneath the slab to prevent radon from seeping into the building. There's also a granular fill, so like a gravel that's underneath the foundation slab. So that promotes airflow to reduce radon buildup. In BC, where I'm located, this is part of our new provincial building code is radon readily remediated new construction for radon, taking these steps to make sure that radon is not an issue in new buildings. And if it is, it's a very quick fix to finish the system by attaching a fan. It's very effective. So Tarion in Ontario, that's a warranty program that addresses radon mitigation in new construction. It provides homeowners with additional assurances that their property complies with radon safety standards. And that's covered if elevated radon levels are detected. So just a key takeaway from this, radon resistant new construction, it ensures proactive mitigation of radon risks at the construction stage. That's what this design is all about. So talking about certification, I've brought up CNERP a few times, the Canadian National Radon Proficiency Program. It's Canada's leading certification program. People with the CNERP certification have gone through extensive training courses and exams to demonstrate that they are well versed in this field. Also, the mitigation factor, so people installing systems, they've gone through a practical session with certified instructors detailing that they know what they're doing. It's extremely important for both mitigation and measurement. You are using someone who is CNERP approved. I've dealt with a lot of clients who have thought they've tested their building before in-house, and they've placed their detectors in inappropriate places that have given false highs and false lows before. And they essentially wasted their money having to test it again properly. So make sure who you hire is someone with this certification. Everyone with this certification has a certification number that is available for you to see, kind of like a police officer. We all have a badge. And if you want more information, if you're interested yourself in getting CNERP tested, cnrpp.ca is the resource. It will walk you through where the courses are, what the exams are, and what the cost is for these courses. But take-home message is really just to make sure you're going with someone that knows what they're doing, so that you're effectively, you're being accurate, you're testing your buildings accurately, and you're having an effective solution if you do have a problem. On the education side of things is CARS, the Canadian Association of Radon Scientists and Technologists. So they play a crucial role in really advancing radon awareness and education and mitigation efforts across Canada. They ensure quality standards are developed and they advocate for best practices. A big portion of their work is educating Canadians. So they are a lot of the people leading when it's Radon Awareness Month. If you're seeing news ads on the radio, a lot of it is coming through KARST because they do the public campaigns, resources, training programs to help spread awareness on the cause. So resources for KARST is karst.ca. They have great resources for businesses, for homeowners, professionals, and directories of certified professionals. as well as lots of educational material, pamphlets, flyers, brochures, you name it. This is a great resource that Karst often pairs up with Health Canada, who I've mentioned several times in this presentation, who sets the standards and the guidelines. They often pair up for educating sessions together. And some benefits of radon testing, other than health and safety of the occupants, there is a BOMA BEST connection with radon. You can achieve BOMA credits if you test your building. So testing your building through a radon risk assessment, that would be hiring a CNERP approved consultant to come up with a radon testing plan and install radon detectors in your building. That will gain you some points. And then also, if the building is high and you have to mitigate it, I believe you can get some points for that as well. And what's really good is I think we do a lot of BOMA testing in my work, and I truly think this is kind of the biggest bang for your buck as far as credits go. As I mentioned, these tests, the alpha tracks, are not very expensive. And especially if you're doing a portfolio of buildings and you can get them in bulk, I can't think of a more cost-effective way to get your BOMA credits other than radon testing. And depending on the design of your building, we mentioned we're talking about testing the lower footprint. So if you're a high-rise building that has a huge square footage, but maybe the square footage of your couple of lower floors isn't that big, this is a very effective way for you to get your BOMA points. Buildings with a large main floor footprint, like a mall, that's going to be a little bit more expensive. But still, this is a pretty effective and cost-efficient test to do. So a great way to get your BOMA points if that's something that you need moving forward. So just to close it off before we take some questions, a few key steps to address radon in your buildings is to develop a testing program, whether you manage a single building or a portfolio of buildings. It's time to develop a comprehensive radon testing program, because the only way to know if there is radon in your building is to test. There is a misnomer that my area doesn't have radon, we're not at risk here. And the short answer is we don't have enough data for me to confidently tell you that today. Also, to use CNERP professionals for both testing and mitigation, use an expert that is trained to do this so you're getting accurate results and effective solutions. And also take your test home too. We've spoken a lot about buildings and workplaces and schools today. I've based that off of the audience I'm speaking to, but your home is also important to test. We spend a lot of time at home. A lot of us are working at home now too. You only need one test in your average house to make sure that you're safe. These are available on our website for homeowners. If you go to pinchin.com, this is something that you can order. It comes with instructions. And as I mentioned, it's pretty cost effective to do this test. So really, my final thought to wrap it all up is that radon is a serious health risk. And by taking the steps of measuring and mitigating your building, you can reduce your radon exposure. It can be a safeguard for all of your building occupants and really contributing to a healthier indoor space for everyone. Testing is the first step to take control of this. So don't wait. You are in the testing season now. It's Radon Awareness Month. So I hope I've encouraged you to test your workplaces, to test your homes. And if you have a problem, it's easily fixed. And again, the last building I wouldn't test is this building that you're seeing on the screen now. If you are living in a treehouse, you are exempt from my messaging today. But if you live or work in a building in contact with the ground, I really encourage you to consider radon testing in your buildings. I'll leave this contact info. This is myself up on the screen. I would love to connect with you if you have any questions about radon testing in your buildings or your home, or further questions about mitigation. I also host these sessions quite regularly for clients specifically. So if you would like me to do a session for your department, I would be so happy to do that. Also, if you want to check out our website, pinchin.com, we do presentations on all kinds of topics, and they're all advertised on our website. So thank you very much.